Alrighty, so now for the last topic of the day. So we learned how to solve quadratic inequalities. So for topic 3, we're taking a step further, and now we're just going to solve polynomials. So we're going to solve something with polynomials with a degree higher than 2. So our directions, we want to solve the inequality, and then graph our solution and write our solution in interval notation. So if there's no real solutions, we're going to write no solution. So example 1, we're given x minus 3 times x squared plus 1, and then x minus 4 greater than 0. So just like solving a polynomial, we're going to use the exact same steps as solving a quadratic inequality. So I'm going to bring this up to remind you what the steps are. So the very first step, we want to rewrite the inequality so that one side is equal to 0, the coefficient of the leading term is positive, and factor. However, in this example, it's already factored. One side is equal to 0. We're golden. So step 1 is done. Step 2, we have to find the boundary points. So finding boundary points. Okay. So what is that? So that we're still going to use the zero product property. So the zero product property, I know we learned like a times b is equal to 0, then a is equal to 0, b is equal to 0, but it works even if it's like a, b, c, d. You can even do the whole alphabet, okay? A would still equal 0 all the way to z equals 0, right? It doesn't matter. So now since we have 3, we're going to do x minus 3 is equal to 0, x squared plus 1 is equal to 0, and x plus 4 is equal to 0. Okay, these are ors. So when we solve, we get x is equal to 3. When we solve this one, we'll get x squared is equal to negative 1. And then when we solve this using the square root property, this is x is equal to plus or minus the square root of negative 1. Okay, but if I took this a step further, this is plus or minus I. Okay, I is not a real number. Okay, it's imaginary. So what does that mean? This means this is not included. Okay, why? Because we just want to look for the real solutions, right? So we don't count the middle ones. And lastly, we get x is equal to negative 4. So since this one, we kind of have stuff that are also not included, I'm going to write boundary points, and I'm going to clearly state. So our boundary points is x is equal to negative 4 and 3. This one, I also put it from smallest to greatest, so when I plot it on a number line, I don't have to think as hard. So with these boundary points, what are we going to do? We're going to draw a number line, right? And we're going to write the boundary points. So I have negative 4 and I have 3, right? And now we have 3 intervals that we want to look at. Okay, so 1, 2, and 3, right? So I prefer to just pick the boundary points and then plug it all in. Okay, so that's what I'm going to do. So let's use a different color. I'll use purple. So we want to pick a number. So what number is between negative infinity and negative 4? I'll pick negative, I don't know, like negative 50. Okay. A number between negative 4 and 3, 0 is always a good choice. And then over here we have 3 to infinity. Just for fun, let's pick 100. Right? So over here, so the boundary, so now we want to find the point. Okay, so we're going to test points. When we do that, so I'm going to look at x equal to negative 50. And we have x minus 3, x squared plus 1. Sorry, I should probably put in what x is. So we have negative 50 minus 3, negative 50 quantity squared plus 1. Remember, I plug it into the x. And so when we plug it in, a parentheses has to go in because it's negative 50 squared, so it's not negative 1 times 50 squared, right? So we have to put the parentheses there. And this becomes negative 50 plus 4, greater than 0. Okay, so when we pick a big number like this, this is a good time to not solve for it, right? And then one thing I do like, so normally we like to pick numbers that are small, like pretty close to our boundary points, but I feel like you have to think a little harder. So this one, I just kind of made them a little more radical, okay, like just more polar. So for negative 50, because without a doubt in my mind, negative 50 minus 3, that is no doubt negative. If I do negative 50 squared, that gives me a positive. A positive plus a positive number is positive. Okay, and then a negative 50 plus 40, that is also negative because 50 is a lot bigger than 40. Okay. So negative times a positive is a negative. Negative times a negative is a positive. So we're left with a positive number. Positive number is definitely greater than 0. So what does that mean? That means that this is part of our solution. Now when I have x is equal to 0, we're going to do 0 minus 3. This is 0 squared plus 1, and 0 plus 4. Is this greater than 0? Right? And in this case, we will get a negative, positive, and positive. Okay. When I do that, so positive times positive is positive, positive times negative is negative. A negative number is not equal to 0. So what does that mean? That means this is no bueno. It's not good. Lastly, we have one more point to test, which is x is equal to 100. Right? So then we have 100 minus 3 times 100 squared plus 1, and then 100 plus 4. Is this greater than 0? So what do I get? I get a positive times a positive times a positive. Okay, so this, when you multiply positives, you always get a positive, which is definitely greater than 0. So what does that mean? That means that this third interval is included. Right? So one last thing we have to do before we plot our points is we have to look at our boundary points. So over here, our boundary point, or our inequality, is strictly greater than. So because it's strictly greater than, we don't have to test any points, right? Because it's already not included. So why do we have to test to see if it's not included when we already know? Okay, so I'm going to look for negative 4, positive 3, and we're just going to color. So it's going to be included here and then over here. Right? So for interval notation, okay, interval notation would be negative infinity to negative 4. 4 is included. Oh, what am I doing? Oh my gosh. Okay, my bad. So, because it is strictly greater than, what does that mean? Our boundary points are not included. So, big circles. So, this is a circle, this is a circle, and then we color. Okay, so my bad. So, instead of brackets, what is this? This is parentheses. There's 2 intervals, so does that mean I have to union them? So, it becomes 3 to infinity. Right? So I want to give you guys an extra credit opportunity. So I don't know, for an extra credit point, what is the set notation? Okay, you get extra credit. I'll do 2 points. Okay, sorry, 2 points. Right? And you guys can just email it to me. Right? I won't make a folder. I'll make a folder on Blackboard that you guys can turn this into. Right? So before we end this, I do want to go over another example because this first example, it was already factored for us. It was very nice. So now, for example, we're gonna solve it. So what do? We're still same exact process. We have to make sure one side is equal to 0, and then we have to wherever the side that's not equal, like that has all the terms, we have to make sure the leading coefficient is positive. So over here, our leading term is x cubed, and the coefficient of x cubed is positive. So we're going to move the terms from the right over to the left. So when we do that, we get x cubed plus x squared plus 9x plus 9 less than or equal to 0. Okay, so how do we factor this? So recall, factor by grouping. So we're just going to put these. So why can I put parentheses right here? Is because of this positive. Since it's positive, we don't have to worry about it, right? As opposed to if it was negative, then we would have to do some extra stuff. So now I'm going to take out the GCF. So this is x squared. This is x plus 1. Over here, this GCF is 9. I get x plus 1. Right? So these are two terms, right? And both of these terms have an x plus 1 in common. So I'm going to factor out the x plus 1. And I'm left with x squared plus 9 less than or equal to 0. Right? Back to my number. So now that we've solved this, okay, so this we can't factor it anymore. Now we're going to test, or we're going to find boundary points. Okay, so we have x plus 1 equals to 0, or x squared plus 9 is equal to 0. Then we get x is equal to negative 1, and then over here when we solve, we get x squared is equal to negative 9. So over on the first example, I actually solved for it and I got plus or minus I. But if you notice, so right here, right? So if you recognize that when you square a number, you never get a negative number, right there, you can just tell me, not a boundary, or not a real number, right? If not, you can go ahead and solve it. That's fine. This would be x is equal to plus or minus square root of negative 9, and then this is actually a very good review. So when we have this, we pull out that I, okay, and then the square root of negative 9, so that is 3i. Right, so this is not a real number, so it's not a part of our solution. So what is our boundary point? Our boundary point is when x is equal to negative 1. Right, so in this case, we just have one boundary point, so we're still going to plot it. Okay. Luckily, one good thing about having one boundary point, one less interval to look at, and you don't have to worry about less than, like, which numbers you plot first and where they go. Right. So this one, we just have two intervals that we have to test. Okay. So what is between negative infinity and negative 1? Let's pick, I don't know, just for fun, maybe negative 1,000. And over here, let's do the opposite. So let's do positive 1,000. Right? So when I check these values, sorry, I was debating if I should do it on the top, but I won't. I'll go on the bottom. So I have x is equal to negative 1,000. So we're testing. Okay, when we have x is equal to 1,000, so I'm going to use this one. Okay, that was me using my mouse. That was very interesting. But we got to check it real fast. So I get x cubed plus x squared plus 9x plus 9. So I get the second line. And if I subtract 9x and 9 for both sides, I will get the first line. So because we get the original equation, the one with my lovely arrow here, is equivalent. So we can test points into that one instead. So what do we do? So this is going to be negative 1,000 plus 1, and then negative 1,000 squared plus 9. Is this less than or equal to 0? So negative 1,000 plus 1, that is negative. negative 1,000 squared, that is positive. Positive plus a positive is positive. Okay. So a negative times a positive is a negative, and a negative is definitely less than or equal to 0. So what does that mean? This is included. Next, we have to test if when x is equal to positive 1,000. So when I do that, we have 1,000 plus 1, and then 1,000 squared plus 9. Right, so this is a positive times a positive. Okay, so a positive is a positive less than or equal to 0? No, it's not. Right, so what does that mean? That means the second interval is not included. Lastly, we got to check our boundary point. So before we do that, we have to look at our inequality. Our inequality has an equal to sign, so we should check the boundary point. However, this polynomial, so all polynomials have, their domain is all real numbers, so the all like negative infinity to infinity. So that's how I know I can just make it a boundary point, right? So, yeah, but if you plug in -1, it will satisfy. So -1 plus 1 is 0, and then -1 squared is 1, 1 plus 9 is 10. So 0 times 10 is 0, 0 is less than or equal to 0. So it is part of our solution. So now the final step, okay, we can't forget the final step. Even though I didn't write it, doesn't mean it doesn't exist. Gotta plot it. So we just have to plot one number, and it is included, and then our solution is just all the stuff to the left, right? So if I write this in interval notation, what is it? So it's going to be negative infinity all the way to -1, 1 included, because -1 does satisfy our inequality. Okay, so just like the first example, I'll give you guys another extra credit opportunity here. This time, so I still want you to do the set notation. Right, so this is extra credit, and then for this one, I'll do 1 point. So you have a 3-point opportunity to get some extra credit, and it'll go towards your homework assignments. Okay. So, so this is it for Chapter 7. Thursday, I will have no videos, and so it's just review day. So if you guys have any questions, please ask. But if not, good luck on your test on Friday, and I will talk to you guys later. Bye.